Hello everyone, welcome back. In this video, we are going to do some more applications of regular expressions. So we're going to start by importing RE. And now we are going to first consider the example of parsing some URLs. And so what we're going to do is we are going to look at the different parts of the URL where you've got a security scheme, a host name, a domain expression, and then a subdomain. And we're going to try to group each of these parts of the URL into their own group using regular expressions. So our string here is we have a bunch of different websites. And then so now what we need to do is we need to come up with a way of encoding this with a regular expression. And we're going to use a pipeline, which should be familiar to you now, which is we're going to have a pattern, and the pattern's equal to R, and then some stuff goes here. And then we're going to do find all on the pattern. So to figure out what this pattern should be, let's go over to Pythex. Okay. So now we need to start thinking, okay, well, these always start with HTTP. And then sometimes there's an S or sometimes there's not. So we could say 0 or more S's. And that'll give us the security key in all of the cases. That should probably be our first group. So let's put that in parentheses. And then it always goes : // That we don't really care about the : // so let's not put that in parentheses. And then usually the next thing is www. But actually, sometimes there's something else rather than the www. It's some other letter like CCLE. So what we can say is we can say www, or using the bitwise OR operator. I'm going to put this in a bracket just to be consistent with my notes. It should work either way. Bitwise OR operator, and then one or more letters. And the this is a little bit redundant since W is itself a letter. Mostly just doing it this way so that way I can show the fact that you can use the bitwise OR operator. All right, so now we get a period. And for a period, we do /period. And then we do another group of some more letters, A through Z, one or more. And then there's typically another period. And then there is some more letters, A through Z, one or more. And then sometimes there's more stuff and sometimes there isn't. So for our last group, what we're going to say is we're going to say /A through Z, or 0 through 9, and then 0 or more. So that's our pattern, where we're able to separate out the different parts of the URL. We've got the security key, we've got the www, we've got the main part, we've got the domain extension like .com or .edu, and then we have the stuff that comes after it. And so we can then plug this in here. And now we have broken down the different parts of a URL into kind of like logical subcategories. And you could use this for some sort of like an analysis of like what goes on the interwebs. So in another example, we have a bunch of data which should be in a CSV, but it's not because somebody was a jerk. And unfortunately, this is how, as you've already seen, a lot of the time real world data is not formatted the way that you'd want it to be. So we're going to try to fix that. So our data here, if we take a look at it, okay, it looks not so nice, but I think these are probably times where maybe it took Andrea 5 minutes and 31 seconds to do something like run a mile and Ben 5:02. And so let's try to get data to represent these times. And so here, our pattern here, as we say, pattern is going to be our something. And we're going to say that our something should be letters, one or more, the first group. So this is going to grab Andrea, Ben, Carl, or Dee Dee. Then a space, which is a /s, one or more spaces. And here's something a little bit new, is I could have done digits 0 through 9, but getting digits is so common, there's actually shorthand for just /d. And then there's a colon, and then again, one or more digits. And so if we do this, we then get a list of the different parts of the times. And we can then go ahead and compute the different parts in the times, where what we're going to say is we're going to create a dictionary where the keys are going to be the people, Andrea, Ben, Carl, and Dee Dee. And the values are going to be 60 times the first entry, where we have to convert to int because by default, regular expressions are going to make everything a string. And then we're going to add on the second number, which would be the time in seconds. And we're going to do this for each line in our parsed code. And now we have a nice dictionary that has everybody's time in the seconds. So what these two examples are meant to illustrate is regular expressions are a very versatile sort of thing, and you can use them for all sorts of nifty stuff. That's it for today. I will see you again next time.